nest-building behavior of the mothers between temperatures. So at 24 degrees, 2 hours after injection, which was T2, the mouse mothers that had been injected with LPS stopped building nests for their pups, or they built really crappy nests for their pups. But then when they lowered the temperature down to 6 degrees, even those sick mouse mothers built nests for their pups. So what this shows is that sickness was motivational. So when their pups weren't at risk, they just felt sick. They let themselves be sick. But when their pups were in danger of dying from freezing, they stopped being sick and started building nests again. So that suggests that sickness behavior is actually adaptive. It's something that we do, or the host does rather, to try and counteract the effects of the parasite. So you can think of it in kind of a more personal way. So when you have the flu or a cold, you have the choice of staying in bed and resting, or going to school and writing your thesis. And what you choose doing is definitely going to be motivated on how quickly your supervisor wants you to finish. So that's kind of what I think might be going. Jonathan's like faster. So that's what we think might be going on with red colobus. So in conclusion, for my speculation of what might be happening, if we do assume that they are demonstrating adaptive sickness behavior, in the short term, that would be a good strategy. So they increase resting and they can get over any sort of infections they have faster. But in the long term, that would be a bad strategy. So they would lose out on potentially mating events, which would decrease their long-term reproductive success. Also, I showed you that grooming decreases with whipworm infection, so there could potentially also be cascading effects. So if they're grooming less, it's possible that they're getting more ectoparasites, which would also potentially have a hindrance on their fitness. So up until this point, I've been talking about Trichuris just at the genus level. I haven't been talking about what species it is. But if we want to shift to looking at the conservation of this, especially in a population of animals that we know are endangered, it might be good to get some more information about what Trichuris is. And luckily for me, that was an entire thesis chapter. And so what I generated was essentially using molecular methods, a phylogeny of samples. And I'm going to do a really poor job explaining what's going on here because it doesn't necessarily matter that much. I just wanted to bring this up to say that I essentially found 3 different groups of Trichuris circulating in the entire diurnal primate community. But just focus on group 3, if you will. And it seems to be kind of positioned within a well-characterized parasite species called Trichuris trichura. And the really interesting thing about this group 3 was it made up 96% of positive samples. So pretty much if you're infected with Trichuris, this is the lineage that you would have. And that's true of all primate species in this community. So humans had it, chimps had it, and then all of the monkeys had it. So now here we have a parasite that has pathological effects in humans, and it seems from what I just said that it might have some sort of consequence on red colobus. So maybe it's not so much of a stretch to say it's doing something to the other monkeys too. So what can we do? So we know what's going on scientifically, but if we wanted to actually help the situation, what can we possibly do about this sort of thing? As much as I would want to, I can't exactly drop some sort of anti-worming laced banana in the jungle and just let red colobus eat it to help try and alleviate their parasite burden. So instead what we decided to do was take kind of an eco-health perspective on things. So eco-health is a really burgeoning field these days, and it's based on the principle that things are interconnected. We're not as separate from nature as we think we are. And this is especially true of parasites, where a lot of different parasites are coming from humans or being transmitted to wildlife. And so I kind of informed this link in my PhD, which was transmission dynamics between wild primates and humans. And if we know that there is a direct link between them, if we alleviate the burden of disease in humans, we can correspondingly, hopefully, alleviate the burden of disease in the primates also. So this project was spearheaded by the Kibale Ecohealth project. It's a really huge project that operates in the communities and works on livestock, primates, ungulates. But one particular project was something that I've become part of recently, and it's funded by the Bill and Melinda Gates Foundation. And it's one of those strategies that's so crazy, it might actually work. So it's called Project HoloFlop. And essentially what happens with Project HoloFlop is we know that several parasites, several soil-transmitted helminths that we know are being transmitted between primates and humans are not only getting ingested, but some of them are capable of actually burrowing through skin. And so walking around barefoot is a really, really good way of getting these infections. And when you're dealing with rural people in Uganda, a lot of times being barefoot isn't a choice, it's a necessity. So one really simple way of alleviating the burden of transmission is by giving them flip-flops. But we also wanted to pair that with some sort of public health message that wearing those flip-flops could actually benefit your health. And so what we did was we put a public health message, what you're seeing up there, on top of the flip-flop in a hologram. So that actually flip-flops back and forth as you're walking. So that's the actual hologram, that's both things that flip back and forth. So they can see as they're walking that this image flip, and so far they seem to really, really like it. So this is what the actual flip-flop looks like. Ghetto, I'll admit, but this is just phase 1. And if we can prove that it's actually doing something, then hopefully we'll get funding for phase 2. And so this was deployed in the summer, and people really seemed to like it. And of course we had control groups. We had people that were dewormed but not given flip-flop, dewormed but given flip-flops without public health messages, and then of course dewormed with the public health message. And hopefully we can show that this sort of thing is causing an improvement in the health of people, and hopefully also the health of the animals nearby. So that's kind of how I linked my PhD to conservation. And the last thing that I wanted to talk about was how we can link our PhDs to science communication also. So Max mentioned that I really like science communication, and I think as graduate students it's hard for us to get the word out about our research, and even harder for the general public to understand what we're doing. And so on that vein, I'm currently developing a blog. I haven't quite decided on the name. It's going to either be Poetize Your Papers or Research Rhymes. Suggestions are welcomed. But I'm kind of looking for a critical mass of poems before I launch it. So thankfully, some of my co-authors for this whipworm project have submitted poems, and here are some of them. If you want to read a funny but crappy poem, look to the left, and if you want to read an actually good poem, look to the right. So I'll give you a second. All right, so the reason I bring this up is a plea for help, because I would like other people to submit poems for this blog and kind of get it launched. So submissions are very welcome, so please get in contact if you want to poetize your papers. And this can be anonymous, or if you want, it can be revealed who the authors of these poems actually are. Okay, so that's pretty much it for me. I really wanted to thank the BGSA for the honor of being able to do this, and then everybody who's been involved in my research. I really appreciate it.